Welcome guys, welcome to another editorial of CODEFORCES. The question is Bear and Friendship Condition. It's from VK Cup 2017 round 1. It's a fairly a good problem. So I thought to make a video on it. I couldn't find any other videos explaining in English across YouTube. So I thought to make a video on it. So let us get into the question. So there's a social network given, okay? And in that social network, if A and B are friends, if x and y are friends, y and z are friends, then x and z should be a friend. Then the graph or the network is said to be a reasonable network. So the question is very simple. So let us look at the test cases. So there are four friends, 1 2 3 4, and there are three connections given between them. That is, one is connected to 3, 3 is a friend of 4, therefore 1 is friend of 4. So this network is reasonable. So let me draw this in my OneNote and make it still clear. So here 1 is connected to 3, and 3 is connected to 4, 1 is connected to 4. So this network is reasonable because x is connected to y is connected to z, therefore x is also connected to z. So now let us look at second test case. So there are four friends again, and there are four connections between them. Let us look into it. 3 is connected to 1, 2 is connected to 3. Here 2 is alone. Here in this first example test case, 2 is alone. Okay, now let us look at the second example. Here in second, 1 is connected to 3, 2 is connected also to 3, 3 is connected to 4, right? Yes, 1 is connected to 3, 2, 3, 3 is connected to 4. Here this network is not feasible because there is no connection between 4 and 2. Also there is no connection between 4 and 1. So this network is not feasible because there is connection between 4 to 3, there is connection between 3 to 1, but there is no connection between 1 to 4. Similarly, there is connection between 4 to 3, there is connection between 2 to 3, but there is no connection between 4 to 2. So this network is not feasible. So answer is no. I hope you guys understood the question. So answer is no. So now let us directly jump into the solution. So here one thing you can see is that these all connected networks will form a set, or they form a component, right? In previous example, let me show you previous example. First test case, there was 4 here in first test case, and there was 2 here. Here 2, which is not connected to any of the there are two components, right? One is this component and one is this component. So 2 is independent of this component because whatever connection may be in this component, it doesn't affect 2. Similarly, whatever connection may be in this component, it doesn't affect this component. So let 2 be connected to 6, let 2 be connected to 4, and 6 be connected to 4. Here I'll remove one network here. Okay, so now 1 is connected to 3 and 1 is connected to 4, but there is no 3 connected to 4. So the total answer is no. If we find across, there can be so many components, right? Out of which, if any one component gives no, then our total answer is no. So that to the network to be feasible, all the component should be feasible, right? And we can solve individual component separately. We can solve the take one component at a time and solve them, right? So when we think about component or connectedness, the first thing that comes to our mind is disjoint set union, right? Disjoint set union is a thing that comes to our mind. So what will I do now? So I'll create a disjoint set union like this. If 1 is connected to 2, 2 is connected to 3, and 3 is connected to 1, they all belong to same component. So their parent may be 1 or 2 or 3, but all of them have same parent, right? In disjoint set union, we have the concept of parent. So all of them have same parent. And how do we check if this component is feasible or not? For that, see, for a network to be feasible, all the element, all the vertices should be connected to all the other vertices. So here it is like this. Now 4 should be connected to 3 also, 1 also. Why? 4 is connected to 2, because before this, let us see, before this 4 was connected to 2, 2 was connected to 1, therefore 4 should be connected to 1. Okay, then 4 is connected to 2, 2 was connected to 3, so 4 should be connected to 3. So here one thing you can observe is that in a component, all the vertices should be connected to all the other vertices. So the degree, what we call in an undirected graph, should be number of vertices in a component. So number of vertices here is 4 minus 1 should be degree of every vertices for a component to be connected. So let me take another example and clear your doubts. If you have any doubt in your mind, I'll clear it. So if 1 is connected to 2 is connected to 3, let me draw a bigger network, 4 and 5. Okay, so 5 should be connected to 2 for a I'll draw a feasible component only. So now 3 should be connected to 4. Total there will be n into n minus 1 by 2, because each component should be connected to every other component, right? So n into n minus 1 by 2, because we cannot count it two times, because if 4 is connected to 3, again counting 3 is connected to 4 is not because it's an undirected graph, so it is n into n minus 1 by 2. So there should be the degree of every vertices in a component should be n into n minus 1 by 2, where n is the number of vertices in the component. I think I have made you guys sure that the, the condition for the graph to be feasible. So now we can directly move into our code. Let me show my code. Okay, so yes, here is my code. Okay, now this I have created a class for disjoint set union, because it is always really good to write our code inside the class, because that looks really great and it's very helpful also. So even in interviews, I would prefer to write inside the class. I would tell even my audience to write inside the class. So I created a class of disjoint set union and a vector of adjacent. This is to calculate the in degrees. Okay, to calculate the in degrees of all the in degree. Okay, here total is, there is no in degree or out degree concept in undirected. Total number of degrees. So now I have created a disjoint set union. I think you guys know about disjoint set union. So this to find the parent, and this I am doing a union by rank. So this disjoint set union to make all the connected vertices should, to make them come under a single component. Okay, now here is my code. I took nm as an input. I initialized my disjoint set union. So first our flag is true, it means that we can get an answer. So I have taken input as uv, and adjacent of u dot pushback v, this because to calculate the in degree. So if here inside 1, 3 and 4 are pushed, right? So in degree of 1 is 2, inside 3, 1 and 4 are pushed, so in degree of 3 is 2. So this to find the in degree. I told you, no, the in degree should be number of vertices in the component minus 1 for all the vertices. So here I have created a map. In this map I will calculate the number of this dsu dot find parent is nothing to it tells that which is our component head of our component, because here let me take, if 1 is connected to 2, 2 is connected to 3 and 3 is connected to 1, head of our component is 1, parent of 2 is also 1, 3 is also 1. Okay, so I have made, I have calculated n here. N is because n is nothing but the number of vertices in a component. For each component, each different component, I have calculated n. Then I'm checking that in this component, this for this component the degree of every vertices in this component head is 1, right? And degree of every vertices should be 2. So I'm checking that whether degree of 1 is 2, degree of 2 is 2 and degree of 3 is 2, right? Using this, that is degree of vertices should be number of vertices in a component minus 1, right? Because there is no self loop. So if I find any of the vertices which is not equal to the component degree minus 1, for example 1, 2, 3, and yes, here degree of 1 is not equal to 2, so our answer is directly no. Otherwise, if I finish this and if I find that our graph is feasible, then our answer is yes, otherwise it is no. I hope you have understood this question. So thank you. Don't forget to like if you did understand the question. So thank you guys.